statistics. So one thing about the IB book that I'm using as a reference point here is it always starts every chapter with a basic review of what you're supposed to know. And I don't know if you remember this from the last chapter or not, but we have a little quiz over the review work. So I would anticipate that we will do that again. So next class we'll have a practice quiz over this stuff we're going to look at here, the review stuff. And then the next day after that we'll have an actual quiz. Alright, so here's what's happening. So we have this set of numbers, the numbers from 1 to 100. We're going to find the probability of choosing a cube. Now, first of all, what does probability even mean? What do we mean when we say probability? Mikey? So it's a fraction or a percentage. I like to start out as a fraction, but it can be expressed as a percentage. And it is, we call it successful outcomes over total outcomes. So by successful, we mean what you want. So this is the number of what you want can happen, options, and this is the total number of options. So in this set of numbers, the total is easy. What's the total? You're going to pick a number out of here. How many total numbers are there to pick from? 100. So your denominator is 100. Now what's your numerator? Your numerator is the cubes. Now give me some cubes. What do we mean by cubes? What are the cubes?
27.
So 27 is a cube. I'll just make a list here. So 27. 8 is a cube. Mikey? 1's a cube. Got 1 cube, 2 cube, 3 cube. What's 4 cube?
64.
64. What's 5 cube?
125.
Okay, now that is out because remember we only have 100 numbers. So how many cubes are there in our list here? 4. So your probability is 4 out of 100, which you're going to reduce to 1 over 25. And if you type it into your calculator, it will say 0.04. And another way of saying that would say 4%, right? 0.04, 4%. Sometimes when we do probabilities, we list them as percents. So if you listen to Chuck Lofton, my very favorite weatherman, he will give the probability of rain as a percent. He'll say we have a 20% chance of rain today. Okay? Easy. All these, now you would never write this, but all of these are perfectly fine ways to write the answer. All right, a group of 15 students ate the following numbers of M&Ms. What is the mean number of M&Ms eaten? What does mean mean?
Average.
The average. The average. Mean is just the math word for average. So how are we going to find the average? This is not a probability question. Remember, this unit's about probability and statistics. So we're reviewing all the basics. Sam? Okay, so in this case, there's 15 of them. We're supposed to be 15 of them, right? So we're going to take those calculators. I gave mine away, so I need your help. And you're going to add these up. So you're just going to add up your list of numbers. So what did you get for the sum? 125. Did somebody else get 125? Okay, so then when you divided that, you got what? 8.3 repeating. So we have about 8.3 M&Ms. So the average number of M&Ms eaten was 8.3. So everybody remember that basic arithmetic. To find an average, you add up what you got, divide by how many you got. Right?
Would you ever?
Huh?
Would you ever?
Well, obviously I can't eat, well, I suppose I could eat 0.3 M&M, that would be kind of hard. In this case, I think we leave it there. But there, if we were talking about, you know, something that shouldn't or couldn't be rounded, we probably, or be decimal, we'd probably round it off. But I think we're okay. Same with 0.3. All right, now, consider this set of numbers. All right, so we got the set 1, 2, 4, 5, 9, 10, 11, 16, 17, 25, 26, and 27. So we have that set of numbers. I'm going to choose one. What's the probability it will be prime? What's the first thing I want to do? How many do I have, right? How many do I have? Because that's going to be my denominator. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You get 12? So I am going to reach in and grab one number out of this pile. I have 12 choices, so that's my denominator. I want it to be prime. So anybody know what the prime numbers are? Anthony? 2 is a prime number. 1, actually, what's the deal with 1? Does anybody remember? 1 is neither prime nor composite. 1 is its own special little number. Okay? So 5 is prime. 11 is prime. 17 is prime.
27.
It's 27.
No.
So, our 1 is a special case. 1 is neither prime nor composite. It's just 1. Very special. Would you agree that I have boxed in the only other prime numbers then? So my probability is 4 12ths, which I would always reduce to 1/3. And probably not write that one as a decimal, because why? It has to be rounded off, and so it's probably just better to leave it 1/3. All right, an odd number. An odd number. 1, 5. I'll do these in different colors, so purple. So 1, 5, 9, 11, 17, 25, and 27. How many odds do I have? 1, 2, 3, 4, 5, 6, 7. So that would be 7 12ths, which doesn't round or reduce. I'm just going to leave it as 7 12ths. That's my probability. A square. Now we did the cubes a minute ago. Are there any squares in this list?
Yes.
There's 1. Isn't 1 a square?
Yeah.
What else? 4 is a square. 9 is a square. 16. 25. 25. Is that it? How many red ones do I have? 1, 2, 3, 4, 5. So your probability of getting a square is 5 12ths. Okay? All right, now we got a chart, because a lot of times when we're looking at data, it will be given in a chart. We're going to be looking at charts, tree diagrams, Venn diagrams, all kinds of data. This one is a chart. So, we surveyed some people. We got men and women. We got, oh, boo this. We got people who smoke and people who don't smoke.
You find shorts kind of silly. It's really kind of.
Nobody does that.
Okay. All right. Now, the student enters the data in the table. A person is chosen at random. And then I'm going to be asked some probability questions. What am I going to have to know in order to answer any of the probability questions? How many there are? So it looks like I've got a total of 59 men and 57 women. So I have a total 116, is that right?
Yeah.
Which means if I want to know what is the probability of reaching in, here's this pile of people, I'm going to reach in and grab a female. It's something over 116. How many women are there? 57. I don't think that reduces, does it?
I don't think it's the point.
You know what, we can check it real quick. Do 57 divided by 116, and then math bracket. So 57 over 116 equals, math, enter, enter, and it stays. That means it doesn't reduce. Okay, next one. What's the probability of getting a male smoker? That would be 12 over 116, which does reduce to what? 329. So the probability of getting of reaching in and pulling a person, it's a man who smokes, is 329. A non-smoker. How many non-smokers do I have? 98? So 98 over 116? 49/58? That is your probability of getting a non-smoker. We need everyone, I need everyone paying attention, because the assumption is that by the time you're this age and this far along in your math career, you know how to read a frequency table. So I need to make sure that you're all clear on what's going on. This represents a big string of data. Remember, a minute ago I had a big set of numbers, just a random list of numbers, for the M&M problem where we had all the kids read these M&Ms and we listed that big string of numbers. Instead of listing the numbers, we can put them in what's called a frequency table. So X is the data point. So that means in my list of numbers I have a 1. This tells me how many ones I have. This is your frequency. So if I were to list these out, I'd have 9 ones. See how it's easier to put it in a table than to list them out? But that's what that means. There are 9 ones. And then there are what? 7 twos. These are the data points. So this chart has 1s, 2s, 3s, 6s, and 11s in it. And then this tells you how many of each of those. So out at the end, if I list them all, there would be 111. You see that? Okay. So you are welcome, if it makes more sense to you, to write all the numbers out. You don't have to do that though, but you gotta find the mean. Somehow you gotta find the mean. And a minute ago, because that's the question, a minute ago somebody said you're gonna add all these up. Right? Well, if you want to list them all out and add them all up, you can. What else could I do? We could take, we have 9 ones, right? So that would be 9 times 1.
Yeah.
We have 7 twos. Remember, this is F is frequency. How many do you have? We have 3 threes. 2 sixes and 1 11. Now, you're gonna add all that up. Right, so 9 times 1 plus 7 times 2, 3 times 3 plus 2 times 6 plus 1 times 11, and who has done that? 55. That is not the mean value. That's all of them added up. What do we have to do to get the mean value? Divide by how many there are. Now wait a second. If you wrote all these numbers out in a list, how many would there be? Well, there's 9 1s and 7 2s, so that's 16. 3 more makes 19. 20, 21, 22. So if you wrote the whole list out, there'd be 22 in the list. Would you agree with me?
Yes.
So we're going to take 55 and divide it by 22. And that will reduce, and it actually comes out to be a nice little decimal, doesn't it? 2.5. Comes out to be 5 halves or 2 1/2. So this question said, find the mean value. And that's what we did. So make sure that makes sense to you, because you're going to have to be able to do this on your own. Find the mean from a frequency table. Okay, this tells you the numbers. This tells you how many times they happen. Got it? Text.